All right, so we're going to take a look at section 9.2. Okay, that's maybe the section we look at for the next couple days. And in 9.2, we're going to learn another mode for graphing. Okay, as far as parametric goes, I've pretty much shown you everything I'm going to. Kinds of things you should know how to do for the test in parametric. Use your calculator to graph. Set all the mins and maxes. Find a start point and an end point for a curve. That's pretty much it. But even in parametric, you still have an x and a y value. Okay? Function parametric uses the exact same type of grid, which would look something like this. That's the kind of paper you use for what we did yesterday and what you've done back in like Algebra 1 and 2. Well, some graphs can be drawn a lot easier in a system called polar graphing. What's different about polar is not only the way we write the equation. Like yesterday, the equations were different from what you're used to. These equations are going to be different from what you're used to. But the kind of paper you would sketch is not gridded. The kind of paper you would use for polar looks like that. Instead of having grids, it has concentric circles on it. That's called polar graph paper. Has anyone used polar graph paper before? No? It's pretty easy. We'll talk about one of the most basic things you can do with polar is just graph a point. And I think that's all we're going to do today, graph points. We're not even going to draw an entire picture, just one dot. Okay. And if you're wondering why there are all these different systems, it's kind of like why there's different tools. And they make different size screwdrivers. Well, sometimes one might work better for one job than another. Polar is the best system if you want to draw a circle. It's super easy. If I want to make a circle in polar, all I have to do, let's say you want a circle with a radius of 3, is type in one number and just set my window. And that's it. That's how I can draw a circle with radius 3. Okay, let me compare that to how you would have to draw a circle the way you're used to, using y equals. Okay? First of all, is a circle a function? Okay, is a circle just yes or no? Okay, Andrew? What does it mean? What's the vertical line test? That's how you test if something's a function. It's not a function, right? It fails the vertical line test. Okay? If you draw a vertical line, it would hit it more than once. If you want me to draw this using y equals, okay, which is function notation, I can't even draw a circle, really. Okay? I can kind of cheat and make it look like a circle. But let me show you all the steps I would have to do. First thing I have to know is the equation of a circle as a function. That's the equation of a circle. Okay, x squared plus y squared equals r squared. And I'm doing it with, what did I do, 3? I think on the last one. So in order to type that into the calculator, what letter has to be by itself? Well, Myler? So all year when we use the graphing calculator, what letter is always by itself on the left? Y. It's always y equals. Okay? The button says it right on it, y equals. So in order to type that in on a calculator, I have to get y by itself. So I could bring x squared to the other side, and then I would have to take the square root. When I take a square root, how many square roots are there? 2, right? Positive, negative. So if you want me to draw a circle with a radius of 3, as a function, I would have to type in all of this. The square root of, I'm going to press 9 because I'm doing 3 squared, just drawing a circle of radius 3, minus x squared. If I type that in, look what I get. I don't even get a whole circle, I get half a circle. So now, if I want to draw the other half, I have to go back in, and there's 2 square roots, the positive. Now I have to type in the negative. 9 minus x squared. And it's not even going to look like the 2 halves connect, but that's as good as I can do. Okay, so if you want me to draw a circle as a function, I have to do all of this stuff and type in all of that. A lot of work. That's what I'm trying to show you. If you say, you know what, you don't have to use a function. You can do it in polar. You just made my life a lot easier. I can type in a single number, get the same picture, and I'm already done. Okay? So polar, very, very, very easy for circles. What is y equals really good for? It's not good for circles, because you got to do all that stuff. But what can you do pretty easily that starts out y equals?
Straight lines.
Straight lines. Lines are perfect for function notation. That means if you wanted to do a line in polar, it's awful. Okay? Function notation is great for lines, bad for circles. Polar, it's the other way around. It's great for circles, it's really bad for lines. Can you do either one in either system? Yeah, you can. But use the right thing for the right job. Okay? Circles, much better in polar. Okay, so that's what polar graph paper looks like. What's that? He's here, don't worry, he'll help you. The pole is generally called the origin. Okay? Sometimes your graph paper is larger or smaller, just like gridded paper. This is a pretty small kind of graph paper. But if I wanted to put on, that one's a little bit more spaced out. That one's even closer together. Generally, when in class, I pretty much stick with that one. Okay. But another name you might see for the origin is the pole. Okay. And now when we graph in polar or we write a coordinate, you don't have x and y anymore. That's not how polar works. You still have 2 things. But to write a coordinate, 2 things you need to tell me about it is 1, how far is it from the origin? And 2, what is its angle? So a point in polar might look something like Brandon's favorite number, comma, 45 degrees. Is that your favorite number? 82?
Yes.
Okay, it's 82. How come 82?
Huh?
How come 82?
It's a long story. I don't want to go into it.
It's my favorite. So that's a point in polar. The distance is 82 units from the origin, and it's at an angle of 45 degrees. Now, just like with x and y's, they can both be positive, they can both be negative, or you can have one of each. So I'm going to explain to you what directions you move in for positive and negative. It's exactly the way you would think and that we're used to. All right, so you start with r. Okay, so r can be positive or negative. If r is positive, it's kind of like x. You start at the pole, or start at the origin, and you're going to move right. Okay, how far right? However many units it tells you. If it's 82, I'm going to go 82 units to the right. Could be a decimal, like 3.5, okay, something like that. If r is negative, you would move to the left. Let me just kind of show you an example. So let's say I wanted to graph the point 3, 45 degrees. The first thing I would do, and I haven't talked about the angle yet. Okay, look at r. R is 3. 3 is greater than 0. So I'm going to go to the right 3 units. That's not the final answer. That's just where we're going to go first. 1, 2, let's put a little x right there. Now from there, we need to move 45 degrees. On a circle, we really don't describe motion as left and right. Okay, when you're moving on the circle, an angle. What are the two directions you could move on a circle? Yeah.
Clockwise and counterclockwise.
Clockwise and counterclockwise. So positive is one way, negative is the other. If your angle is positive, you move counterclockwise. If it's negative, clockwise. It's exactly the way we've been doing this all year. Okay, and when you move clockwise or counterclockwise, it's from where you ended at step one. It's kind of like when you have an XY coordinate. You move left and right first, and then from that spot you move to, then you go up or down. You don't start over and go back to the origin. Okay, so in this problem, we move 3 units right. 45. 45 is greater than 0, so we're going counterclockwise. Okay, counterclockwise is this way. In case you're not sure. Clockwise, this way. On my particular graph paper, I think each line is 15 degrees. Different graph paper could have different markings on it, but this is 0, 15, 30, 45, 60, 75, and 90 is straight up. Okay, so 45, 1, 2, 3, right there. That's how you would graph that point. Right, 3, 45 degrees. And that's it. So we're just going to practice graphing a bunch of points. This is a positive, positive, and I'll show you everything. Negative, negative, all that stuff. Okay. Any questions on which way to move for R, which way to move for theta? Okay. And if you're wondering, can I graph a point on the calculator? No, not really. Any more than if I said to you, graph the point 2, 3. You can't really graph a single point on a calculator using this screen. Okay. Is there a way you could kind of do it? Yeah, but that's not really what we're going to do. Okay. So that was our first question. Okay, so I already did it, so I'll just do it again real quick. 3 units to the right. 45 degrees. Any questions on that one again? Okay, so let's do a different one. What you could do if you wanted is you could just draw this kind of grid once in your notes, make it, maybe take up half the page, make it big enough, and just label each one. And then as we label other ones, you could just put example 1, 2, 3, 4, 5. Okay, however you want to do it. And if you don't want to do it that way, just redraw the grid every time. Okay, let's try this one. -2, 75 degrees. All right, so Caitlin, what would be my first step? Starting at the origin, which way would I move? Exactly, I'm going to go 2 to the left. Temporarily, I'll just put a little mark there to let you know that's where I'm going to start from. And Ezekiel, now I'm going to move 75 degrees which way? So with the angle, left and right aren't really movement options. These are your 2 options you can say to me. All right, so he said clockwise. Let's double check our angle. So as long as we have an angle less than 0, we're going to go clockwise. Is my angle less than 0? Counterclockwise. Okay, so counterclockwise, 75 degrees. Probably about right there. If I went all the way to the axis, how much would that be? Michael? If I went all the way to the axis with that point, what would that be?
45 degrees.
90.
90.
It would be 90. Yeah. Okay, so I know my angle's a little less than 90, so I'm going to stay a little shy of the axis. Okay. On a test, as long as you're in that area, I'd give you points. Okay. Any questions on that one? All right. 3, -60. Ian, can you tell me how to graph that one?
So go 3 to the right.
Yep, we're going to go 3 to the right. So I'm just going to start there.
60 degrees clockwise.
And then 60 degrees clockwise. Okay. If I went halfway, Ian, how much would that be?
45.
45. So let's just go a little bit past halfway. Again, anything in that area would be fine. If your answer was up here, I wouldn't give you credit for that. If it was down here, that's too far. Okay, so just make it look like it's a little bit more than half. Maybe I should go a little more. That's pretty good. Any questions on that? All right, so we did a positive, negative. That's a positive, positive. Negative, positive. So let's try negative, negative. Okay, Wyatt, what's a little different about how this point is written? It's in radians, which is only a problem if you don't understand where that is in radians. If that's a problem, you could always take and do what with it? Matt? What could we do with that if radians is a problem?
Change to degrees.
Yes, we could just change to degrees. Okay, what's negative 3 pi over 2 in degrees? Exactly, right? Pi over 2 is 90. This is pi over 2 tripled with a negative. So if you triple 90, you get 270, make it negative. Okay, so we're graphing -4, -270. Right, so Hannah, how would you graph that one?
Me?
Yeah.
See, negative 4. Left. Negative 4 to left.
So left 4.
Yeah.
Start. I'm going to start there.
Counterclockwise 270.
And then we have a negative angle.
Yeah.
So which way do we go for negative?
Clockwise.
Clockwise. So we're going to go just like the hands of a clock. Clockwise 270. Well, 270 is 3/4 of the way around. Right. Okay, this time, what I'm going to do is I'm going to draw it out in black, kind of showing you how I got there, because I want to show you something. I went left, and I went around that way. Can anybody give me a different coordinate that would get me to that same spot? Besides -4, -270. Yep.
It'd be positive 90.
So give me, what's the whole coordinate?
-490.
Sorry, I didn't hear you.
-490.
Thank you. -4, 90. So let's give it a shot. -4. You go left 4, and then 90 counterclockwise. Yes, that is another way to get to that point. Can anyone give me a third way I could get to that point? We'll do this one maybe in green. Yep, yeah.
4 -90.
Let's try it. 4 -90. I think that's going to be perfect. 4 to the right. And 90 clockwise. That's good. And now there's one more way we can get to that point. So we've got the negative, negative. We've got negative, positive. Positive, negative. We don't have the positive, positive yet, which I think is probably the easiest if you like positives. Yep.
4, 270.
4, 270. So, right 4, 270 counterclockwise. Kind of drew it off a little bit so you could see all the arrows. So, what I'm trying to show you is there are 4 ways to get to a point in polar. 2 choices for your radius, left, right. 2 choices for your angle, clockwise, counterclockwise. Gives you 4 total options. Now, if we go back to just the way you guys are used to graphing, that point right there. What's the coordinate of that point? 3, 2. Can you give me another coordinate that would still get me to that same spot? Like we just did. We came up with 4 different ways to get to the same spot. Can you do that here? No. Okay. When you're doing this kind of graphing, there's one and only one way to get to exactly every point. When you do polar, there are 4 ways, okay, to get to every point. Why am I showing you that? Because when I ask you to for an answer on the test, if the answer is a coordinate, maybe I'm going to write this as my multiple choice answer, and you're going to come up with that. Well, you got exactly the same thing I did. You just wrote it a different way. Right? So you just have to kind of know how to figure it out. And there's all kind of patterns you could try to figure out. Like if you make the radius negative, you just add 180 to the angle. For me, the easiest way to figure it out is to sketch it. Then I can see visually how to get where I need to go. Okay. But again, you could try to come up with formulas if you want to. Hey, any questions on that? Some people have mentioned, well, isn't there really like an infinite number of ways? Because couldn't you go right and then go around and keep going and then stop the second time around? Yeah, but that's just a repeat. Okay, going around extra times is not a different way. I still went right, I still went counterclockwise. I don't care how many times you go around. Okay? Questions on that? All right. So let's try this one. 0 pi. Okay, so Colin, what's my radius on this one?
Be pi.
Pi is my angle.
So 0.
0. 0 is my radius. What's that going to look like? Radius of 0.
It'd just be the dot in the center.
Okay, the dot's going to stay at the center, but then the angle is pi. So what's really happening here? The what?
The dot's turning.
Yeah, the dot is turning. I mean, so you've got a dot, and then it's being rotated 180 degrees. There's your sketch. Okay, just make sure you do the rotation of the dot, because I'm going to check for that on the test. I'm kidding. I'm not checking. But there's your dot.
That's so confused.
What?
I was like, what do you mean?
Never mind. Don't worry. Just put a dot at the center. Okay. 0, 0 comma anything is just a dot at the center. Doesn't matter if the dot spins in place. As you can see, spinning in place doesn't really change how it looks. Okay. Let's switch it up and put the 0 in the second spot. Is this going to be a dot at the center? No. Where is this one going to be? 2.5 units to the right. So 2.5. So if the second number is 0, what's going to end up happening is you're going to just move left and right. That's all. If the first number is 0, the dot stays at the center. Okay, so I've tried to show you an example of every different case you could have. Positives, negatives, 0. Any questions on that? This is another positive. Does anyone need to see another one? We're good? This is one that actually, if you graph 3 180 or 3 negative 180, it wouldn't make a difference. Because if you go halfway around, it doesn't really matter which way you go to get halfway around. Okay, but try to remember the correct way to go. Okay, so I already pointed this out to you. There's more than one way to write a coordinate in polar. How many ways did I show you there are? 4. It's 4 ways. So more than one, in parentheses, I'll put 4 different ways to graph a point in polar. Okay, so I'm going to give you a coordinate, and I'm just going to have you write it all 4 ways. Okay, just try it on your own. So let's write coordinate 2, 30 degrees. There's 3 ways besides the one I just gave you, so total of 4. So write 2 30 degrees, 3 different ways. Okay, and something like this doesn't count. What did I do to get 2 390? All I did was add 360. So that's just like if here's your circle, you went 2, right 2, 30, and then you just went around an extra time. No, that doesn't count. Okay. So I'm looking for the negative, negative, positive, negative, negative, positive. Okay, and my suggestion would be to visualize it, and then you can see it out. Okay, so just take a minute and see if you can figure out the 3 different ways. Okay, so we're going to try to write this 3 different ways. Okay, what I'm going to start with is 2, 30, just to get an idea of where that point is now. Okay, was anyone able to come up with one other way to get to that point? Yep.
2 negative 330.
2 negative 330. Yeah, perfect. You go 2, wait a minute, let's see. So 2, actually no. Negative 330, wait a minute. I'm thinking ahead. You're good. 2 negative 330 works. Yep. So 2 units to the right, and then take the long way around. Perfect. So we've got the positive, negative. Is anyone able to come up with the negative, positive? Yep. Mike. Negative 2, what'd you say? 150. All right, let's check it. So we know this little section right here is 30. Okay, we know that's 30 because that's how we drew it. So if we go negative 2, well, let's take a look. So we're going 150. Well, I think you're going to need negative 150. Because if you want to go negative, that's the clockwise direction. Going that way is negative. So you're almost all the way around, but you're 30 degrees short. So that's why it's negative 150. Okay. And what about the last way? This would be the negative, positive, negative. Negative, positive. Negative, positive, yep.
Negative 2, 210.
Negative 2, 210. Yep, let's check it. So 2 units left. Go all the way around, but then you've got to go that 30 more. Perfect. Great. So my advice is most people find it easier to do it in degrees than radians, because once you throw pi's in there, it gets confusing. So change it to degrees if you need to. All right. Okay, so the last thing we're going to look at for today is how we can take a point in polar, like all the ones I've given you, and change it to rectangular. Okay, in polar, what will they give you? They give you two things. What are the two letters they give you for a point in polar? Yep. You want to just give me one of them, Mike?
Radius.
Radius? Yep. Can someone tell me the other letter they give you in polar?
Angle.
The angle. So our goal is to turn it from polar to rectangular. What are the two letters in rectangular? X and Y. So you're going to start with an R and a theta, and when you're done, you're going to turn it into an X and a Y. Okay. Easiest way to figure out how to do this is make a picture. Let's pretend that they gave us a point in polar. Right there. And the coordinates of it are R, theta. What do you think I'm going to try to draw in this picture that we've done this type of thing before? I'm going to make a triangle. Okay. How do you think I'm going to make a triangle? What am I going to do first? Yep.
Draw a line from the origin to the point.
Yep. I'm going to draw a line from the origin to the point, and that distance is R. It's the distance from the center of the circle to the circumference. It's the radius. Okay. I don't quite have a triangle yet. So what else am I going to do? Add one more thing to make that a triangle.
So you have to go straight down to the axis from the point.
Yep. I'm going to go straight down to the axis, perpendicular to the axis from the point. And there's a 90-degree angle. All right. Theta is that angle right there. It's the angle from the x-axis up to your point. Our goal is to find out how long is the bottom side of the triangle and how tall is it. If you can find those two things, that's the x and the y. How far to the right, and then how far up. So, let's start with the two things that you're going to know in the problem. R, theta, and let's start with x. What trig function could I use in that right triangle that would involve x and r? Yeah.
The Pythagorean Theorem.
We're going to use Pythagorean Theorem tomorrow when we go the other way. You're going to be given the x and the y and have to find the radius. But we'll hold off on Pythagorean Theorem for now, but we will use it tomorrow. Yep.
Cosine?
We're going to use cosine. Cosine of your angle equals adjacent over hypotenuse. Okay, now the goal here is to get x by itself. So Hannah, how would I move the r to the other side?
I don't know.
Not sure? Well, think about, we got r in the bottom, right? We've divided by r. So how do you undo dividing by r?
Multiply.
By?
Cosine. Oh no, by r.
By r. And there's your formula for how to get x. It's r cosine theta. Right? So once you know your r and your theta, you fill them in. That tells you x. Does anyone have a guess what y is going to be without going through the whole right triangle? Yep.
It's just r sine. R sine theta.
Yep. It's going to be r sine theta. So those are the two formulas you need to convert from polar to rectangular. And now we'll finish up just triangle. Does everybody have the two formulas? All right. Okay, so here's our point. R is 2, theta, negative 200. So let's convert it to rectangular. 2 steps. Let's get the x value first. So what we're really doing without drawing a picture is we're making a triangle and we're finding the base and the height of it. But it's all built into the formula, so we don't have to draw anything out. What would be my formula for x? What times what?
So 2 cosine negative 200.
2 cosine negative 200. Okay, and we'll type that in. What would be my formula for y?
2 sine negative 200.
2 sine negative 200. All right, for this, because the problem was given in degrees, make sure your calculator is in degrees. Degrees, and see what we get. I knew it would work eventually. I'm persistent. 2 cosine negative 200. Buttons are not quite working. All right. Almost the same thing anyway. Yeah. All right, so we get negative 1.88 if we round it. That's good enough. Negative 1.88. And for y, just change cosine to sine. We get 0.68. Okay, so converting that point to rectangular, just write it as a coordinate. Negative 1.88, comma 0.68. Okay, that's how you change it to rectangular. Okay. Now I'm going to show you something that's kind of neat, something you can do on the smartboard. So what I've done is I graphed the point 2 comma negative 200. That's 2 units to the right, negative 200 units clockwise. Halfway would be 180. The first mark would be 15 more, that's 195. So I went a little, it's kind of hard to see, but I went a little past it. Now, if I graph that accurately, what I can do is I can take a XY coordinate plane, drop it right on top of that one. That point will stay exactly where it is, and it should look like that point is almost 2 units to the left and a little more than halfway up. Okay, so we can kind of check our answer. All right, so let's make that bigger. The only thing I have to do is make sure I use the right scale graph paper. I think this is the large one. So we're looking for negative 1.8 up 0.68. So let's see. Does that look like it's at about negative 1.8 up 0.68? Yeah, looks pretty good. So just kind of changing the background behind the point, I'm able to check my answer. That's the original in polar. That's where it would be in rectangular. Any questions on that? All right. Does anyone have a question how you would do this one? Change to polar or change to rectangular? What would I have to do different here that on my calculator? Can use the same formulas. Yep.
Put it in radians.
Put it in radians. Okay. Don't waste time changing this to degrees. Just put your calculator in radians and do the whole thing in radians. But other than that, it would be the same. Does anyone want me to go through it? All right. So I'll leave that one for you. Well, it's up to you. Do you want to do an extra thing tomorrow with rectangular to polar, or do you want to finish it today? I'm going to do it all. It'll be more tomorrow if we do it tomorrow. It's up to you.
Today?
Today?
Yeah.
All right. Well, we'll finish rectangular polar and then we won't do it tomorrow. So Colin had mentioned something about the Pythagorean Theorem. That's going to come up here. Okay, so when we convert back the other way, we're going to use what he said. So now I'm going to give you the x and the y. You're going to work backwards to give me the r and the theta. What trig function haven't we used yet today? Tangent. Okay, we haven't used tangent. We're going to use it right now. That's going to convert us back the other way. Okay, so here's kind of a diagram like we had before. I'm not going to really go through in too much detail. I'm just going to give you the formula. X squared plus y squared, that gives you r squared. So you can use the Pythagorean theorem to get your radius. Okay, because you'll know this and you'll know that. And what trig function are you going to use? Well, look at the two things I just circled. Opposite, adjacent. Opposite over adjacent is tangent. So you have something like this. The tangent of y over x. And then your goal is to get just the angle. So how do you get rid of tangent? Inverse tangent. So I'll write that out nice and neat for you. Okay, so to convert, first thing we'll do is we'll graph it and figure out what quadrant our point is in. Example I gave you was quadrant 1. So graph the point, determine the quadrant, and now find both things you need. You need theta and you need r. There's your formula for theta. Tangent theta equals y over x. The only thing I'm going to do is write it like that. Inverse tangent of y over x will get theta by itself. Okay. Inverse tangent works fine as long as you're in quadrants 1 and 4. If you're in quadrants 2 or 3, you have to make a small adjustment to it. You still have to do inverse tangent, but then you have to add 180 if you're in degrees, or add pi if you're in radians. And that has to do with how inverse tangent works. Okay. Technically, inverse tangent would never give you an answer outside of quadrants 1 and 4. So if you want to get an answer outside 1 or 4, you have to add something to it. And that's how that works. Now, so what I've done so far is the first formula covers quadrants 1 and 4. The second formula covers 2 and 3. That doesn't cover everything though. Where else could I be besides in quadrants 1, 2, 3, or 4? I could be on an axis. If you're on an axis, these formulas don't work. Okay, the reason they don't work is, let's pick that one. I don't know what the y value is. It went up. How much? I don't know, 5, whatever you want. But what's the x value? 0. If the x value is 0, what happens if you do something divided by 0? What do you get? Undefined, right? So when you're on an axis, don't try to use one of those formulas. You just have to know these 4 numbers, which, bless you, you probably already do. 0, 90, 180, 270. How will you know if you're on an axis? Easy. One of the numbers in your coordinate is a 0. 0, 5, 5, 0, something like that. Okay, so that's how you find your angle for quadrant 1 and 4, 2 and 3, or if you're on an axis, it's one of those. The radius is just what Colin said, the Pythagorean theorem. We already said that. Okay, so I'll finish up just by showing you how to convert one coordinate from rectangular into polar. Let's do, that one's easy. Let's just do the first one, 3, -5. This one is more typical. This one you could pretty much do in your head because the angle is on an axis. So that's kind of a special case. So we'll finish up with example 10. Okay, so David, what are the two things I need to find? I have x and y.
You need to find r and theta.
I need r and theta. Okay, so eventually I'll put my answer in that box. All right, it doesn't matter which one we do first. Let's do the radius first. AJ, what's x in my coordinate? 3. And Curtis, what's y? -5. Okay. So we're using the Pythagorean Theorem to get r. So you get 9 plus 25 gives me the square root of 34. And that's it, that's r. Any question on r? Okay, so that's half of it. Last thing I need to do is figure out my angle. Now the angle depends on the quadrant. That's why the first step I said is you should graph it. In fact, you don't even need to graph it. If you can figure out the quadrant without graphing it, that's fine too. What quadrant is 3, -5 in? It's in the 4th. So there's your formula. Inverse tangent of y over x. Y is -5, x is 3. Okay, so just type that in and see what you got. Let's stay in degrees. Second inverse tangent. Okay, so we get an angle of -59.04. Okay, so my final answer, just write r comma theta. R comma -59.04. I'm not going to go through all 4 ways you could write that. We did that earlier. But remember, there's 4 different ways you could write it. Okay, so we go over the homework. We can, if we need to practice a couple more converting between polar and rectangular, we can. You'll probably see at least 2 or 3 problems each on the test of this stuff. 2 or 3 convert to polar, 2 or 3 convert to rectangular. Okay, so the homework tonight, it's on 492, 1 through 14.